Hello all, welcome to Tech with SAS. In this video, we will talk about load balancer. Load balancer is a component that sits between app servers and the client because in modern day applications or website they are serving thousands or even millions of customers in a concurrent state, right? So how do we make sure that every server in the application is getting a fair amount of traffic and no server is getting overburdened or no other server is getting like not getting much traffic, right? Maybe it is not utilized properly. So for distributing the traffic among the app servers and utilizing them at optimum level, we use the load balancer. So you can say that load balancer is basically a traffic prop which sits between the server pool and the clients, and it distributes the traffic to the various servers, right, based on various algorithms. Okay, so basically, it is making sure that our application is highly available and reliable. How? Because sometime if one server goes down, right, so it won't impact how we are serving our clients because now load balancer will not send those requests to that server which went down, right? Now those traffic will be served by the other servers. And also, suppose you want to, because you have a lot of requests coming in and you want to scale your application quickly and you are adding couple of servers to your application infrastructure, then load balancer will start sending those new requests to the new servers, right? So this is how it makes sure that our application is highly available and also reliable at the same time. So it's very critical component in terms of how we are managing our websites or applications. So in a nutshell, we can say they distribute a client request across multiple servers so that it maintains the highly available application along with high reliability. Yeah, this thing we already covered. Then it also gives us possibility to scale up our servers or scale down, right? So suppose you have sometime uh, peak traffic coming in. Maybe you have some celebrity posting about your product, and then you see a surge of traffic. Then you can add new servers. And then suppose the traffic is now normal, then you can remove those very easily. So load balancer is helping us scaling up, scaling down, and also making sure that our application responds to the dynamic environment of like dynamic request coming maybe high or low at some point of time. So also, if you talk about the various flavors, like the flavors of load balancer are basically like hardware or software based load balancers. So like the hardware based like load balancer means that you have to purchase the machine along with the proprietary software installed into that. Okay. So maybe initially if you have like a small application, you can purchase it, but in the longer run, if you are trying to add more and more server to your infrastructure, then it's really adds your cost, right? So it's always good to use the software-based load balancers because those software-based load balancers are like less costly and you can use or configure them in your own machine as well. So yeah, this is about the load balancer. So let's understand now the various types of load balancers. So we have two flavors of load balancers. First is the network load balancer, which operates at the layer 4 or transport layer of the OSI model. And this basically works on the TCP or UDP protocol. In this, the content of the data packet is not analyzed and it is just sent to the application server based on the IP addresses. But on the other hand, the application load balancer, which operates at the highest layer of the OSI layer, that is the application layer, is able to make some decisions based on the content of the packet. So it can make decisions on the routing, like where to send. Because suppose you have a request coming for the static content, like suppose the client need the static images or videos, right? And then if you can analyze that data packet, and then this load balancer can directly forward that request to the server, which can serve it easily. Okay. On the other hand, suppose you have some data, which is like a order summary or some transactional data, that can be verified via the data packet, and it can route that traffic to the particular app servers, which can serve it better. So these are the two flavors of the load balancer. Application load balancer is like more configurable, and it supports based on the traffic data packet content. It is like gives more flexibility to the developers and architects to configure the application and optimize it in a better manner. Now let's see various algorithms which are used for load balancers. Like one is the dynamic and second is the static load balancing algorithm. So in dynamic algorithm, we always account for the current state of each server and distribute traffic accordingly. So if one server is basically able to respond fast, then we will send more traffic to it. Or maybe if some other server is not responding very fast, or maybe it's like overburdened, so request will be going in less number to that. So like based on the current situation, dynamic algorithm can adapt and fine tune the traffic going to each server. On the other hand, the static load balancing algorithm will basically not account for the current state. It will basically distribute traffic based on the pre-configured algorithm. Okay, so whatever algorithm or the logic we built in initial time, right? That is going to be used over the time. It will not adapt, it will not change the behavior based on the current situation of the app server. So let us see various algorithm, like to understand them briefly. So first is the round robin algorithm. In that, load balancer will send requests to each server one by one. So suppose first request come to load balancer, that is going to send to the app server. Then second is going to app server 2. Likewise, it will send these requests one by one to the each server. So in second one is the weighted round robin. In this, the administrator can assign some weights to the server. Maybe because like one server is like more heavy duty, it has more RAM or more storage, so it might have like more weightage in terms of traffic absorption. So the admin can assign some weights, and then a load balancer can send request one by one based on those weights to these servers. The third one is the least connection algorithm. In that, load balancer will see, okay, at the given time or maybe at current time, which server has the least connections, okay, which is like not serving as many as requests as other servers. So the new request is going to go to that server. So it will check for the current state. So you can say that first two are the static algorithm, and this one is basically a dynamic algorithm because it is accounting for the current state of the application server. Then fourth one is similar, like it will assign some weights. Okay, so if it will have admin will assign some weights to each server based on its capabilities, and then the LB is going to check the which has the least connection in among all the servers which are active, and then send the request accordingly. I mean, also like we also have this response time based where we check, okay, which server is responding fast or which is like lagging behind. So based on like the fastest server is going to serve more requests in this algorithm. Then we have a hash based algorithm. So in hash based, like we define some keys like maybe IP address of source or destination. Then based on some hashing function, we find the server. Okay, then we assign that traffic. I will cover this hash-based algorithm because it is a big topic in a separate video. So then we understand in a better manner. So yeah, for now, that's it for load balancer. And this is basically a basic presentation, a basic video on this. So yeah, thank you very much for watching. See you next time. Please leave your comments or questions if you have any, and please subscribe my channel if you like the video. Thanks a lot. Thank you for your time.